Okay, thanks everyone for joining. My name is Kalla. I'm part of the platform software team at Arista Networks.
And I'm Choi from Meta.
All right, so today we're going to talk a little bit about BMC use case on a network switch, OpenBMC stack, and supporting FBOSS on network switch. So firstly, for those who don't know what is a BMC, it stands for Baseboard Management Controller. So it's a little system-on-chip coprocessor that does some platform management. And it's typically your out-of-band access into a device. It gives you some nice features like you're able to power cycle the system, access console offload, and it's something that's pretty prevalent in the server world. And the stack that typically supports this is like the OpenBMC is the most common one. So this is a open Yocto embedded Linux. It's a full Linux system, U-boot, and Linux. Next, I'll talk a little bit about the Arista and Meta joint development. So there's a lot of history here. We've been working with Meta on the Arista side to co-develop many switches, going from prototype to production. So traditionally, the switches that we provide are BMC-less. They don't have a BMC. But in 2017, we co-developed the 128 by 100 gig Tomahawk 3 switch, and we added a BMC to our design. And in addition, we followed that up with 200 gig next generation, took those from prototype to production. Those are what we're going to call in this talk BMC classical implementations, and Mike will get into that in a bit. We followed up with some top-of-rack switches, took that from production into production with ORV2 and later ORV3. And then finally, the most recent sort of development was our DSF solution. So this is a Jericho-based solution that's disaggregated, fully scheduled. You might have seen it in some other talks. But this one, we sort of transitioned into what we call BMC-Lite architecture. We also added support for our Tomahawk 5 switch. So here we'll talk a little bit more about how this has helped us move quicker in MPIs, new product introductions, and sort of some of the details there. So with that, I'll hand it off to Mike to talk about some of the things we've
Yeah, thanks, Dean. Let's start with BMC-Lite architecture before our success story. Arista and Meta used BMC-Lite to quickly deliver reliable switch products. Meta previously used BMC classic architecture, but we pivoted to BMC-Lite last year for faster product deployment and development. With AI cluster growing, Meta's network software team called FBOSS had to deliver network operating system for several platforms at once. And we adopted BMC-Lite architecture to add powerful features faster with less amount of software work. Next page, please. As you can see here, in BMC-Lite architecture, platform management features moved from BMC to the main x86 CPU. But BMC still oversees the main CPU, manages it, reboots it, reads the console inputs, and so on. This let Meta add stronger software features and integrate switches into Meta infra better. BMC Classic was good, but it was somehow limited by its memory and compute power. And on top of that, we made our platform management services config-driven. What this means is that now for new platforms, we just write JSON config files, and we don't need to add any boilerplate code anymore. And actually, on Arista switch products, it was Arista that developed these config files, debug it, and stabilize it. The good things about this was that this greatly cut down the joint debugging effort and therefore sped up the projects. Next page. Here are simple diagrams comparing BMC Classic and BMC-Lite. As you can see here in BMC Classic, BMC manages the platform and uses mostly the REST API endpoints only, which was enough but somewhat limited. In the new BMC-Lite architecture, x86 CPU manages everything and uses Drift and other secure Meta protocols. You may think that the main CPU now has become the single point of failure, but it is still managed by BMC. If CPU crashes, kernel panic happens, anything happens, BMC can still read the console input from the CPU, still read the log, still check the sensors, therefore giving the data to the auto-remediation logic and revive the CPU immediately, if this is not the hard failure. Now, all yours, Dean?
Yeah. Yeah, one thing to call out here is on the classical implementation, the BMC has to sort of, from a hardware perspective, connect to all the various SM bus and control interfaces. This is greatly simplified with BMC-Lite. You sort of have a cookie cutter BMC-Lite implementation. It's light on the hardware implementation, and we're able to sort of quickly bring switches to support it, and this helps on the execution. Yeah, so just overall, BMC-Lite in the new paradigm, it still does out-of-band management. You can still SSH and do console offload. As Mike mentioned, you can debug things if your CPU went down. You can power things off. And the image here can now be common across platforms or very simplified. So there's less chances of getting it wrong. On the main host now, there are some things that have migrated over in terms of responsibility. So things like firmware upgrades are now done by the host OS, so in this case, FBOSS. There's responsibilities for reporting all the sensors, doing all of your thermal management. And this is typically a single host that manages it on switches. I don't think I've seen a multi-host implementation yet. And then the data plane obviously is all managed by the hosts in this case as well. So all of your pluggable transceivers, retimers, ASICs, everything is managed by FBOSS here. And the big improvement, I would say, is it's very config driven now. So yeah, a lot of it is in the config file, a lot of the details on the SKUs here. So this is a bit of a diagram just showing an example of a Broadcom-based switch. The boxes in red here are the data plane or NPU items. So here in FBOSS, they are leveraging the SI, the open standards, and they have a Broadcom SDK in this case, and a SI that's provided by Broadcom in this case. And Arista, we'll provide a couple of things. One is we call the board support package. So this is going to have all the kernel drivers and sysfs, to the config files. And these config files are basically going to be things that Arista delivers in this case for all these services. So some of these service examples are like Platform Manager. This is the service that basically figures out what box am I, loads all the kernel drivers. Sensor service, as it sounds, it aggregates the sensors and exposes it through Thrift or other methods. Fan service for thermal management. So this is going to look at your ASICs, your optics, and decide how fast to run the fans. And then you've got the agents that do all the programming of the network chips. So with this, there's also been improvements on the OSS test suite. So everything here is open source. So we can run these tests and give confidence to Meta that when they get the box, there's a lot that's just going to work on day one.
That has been very helpful.
Yeah. Yeah, finally, just a call to action. So, we'd love to hear more about BMC use cases specifically on network switches. I know there's more interest now, especially with liquid cooling and some potential applications. I invite you to contribute to OpenBMC. This is an open stack, as well as FBOSS OSS. And there's a lot more details on the hardware architectures that we discussed that's been published recently as well. So with that, thank you for listening.
Any questions? I guess not. Thank you, Mike and Din.